Okay, so here we are on a Wednesday. I am going to do the same thing on Friday. I'm actually driving up to spend the weekend with my daughter's family and all, so that the Friday class will be on the website, so it won't be live in the room again. With that, though, the goal today is to finish up Chapter 6, and that way in the video that I'll make for Friday, we'll start fresh on Chapter 7. And the next exam we have is really based on up through Chapter 6. So we need to be thinking about the date of when that exam is. So nothing is locked in right yet, but when I was looking at the calendar, or a student came up at the end of last class and said that the week of the 1st of November was a mess, the late October, 1st of November. So tentatively then we'll be thinking about Friday the 8th of November, but it's not official yet. Right? We'll let you all think about it, which is about a week later than I'd kind of like to have it, because you know how if the exam goes through Chapter 6 and then here Friday I'm going to start a thing on Chapter 7, I'm afraid that people will say, well, I'll watch that later, and you get behind and you try to catch up and things get kind of crazy. So to me that strategy doesn't work too good to wait off on it. But with that, tentatively then we'll look at the 8th, but it hasn't been locked down, like it's not on our Canvas page yet. Okay, so what we're working on, we're going to try to finish up Chapter 6. We're analyzing these spherical mechanisms, and we did the pentagon last time. So what we did with the pentagon, the kind of problems that we were doing was given all the alphas, so I know what all my link sizes are. And then this is a 2-degree of freedom mechanism. So if you give me any 2, I can solve for the other 3. And the way we attacked it was, of the 3 remaining angles, decide who you want to go for first, and then go into the toolbox and try to find, or you will find, the one equation, one unknown. So to attack this again, before we ever did the problem, we built our toolbox. We took S5 in the 5th and brought it back to the 1st, going 2 different directions, and generated fundamental equations, da-da-da-da-da. And we got a giant toolbox. So let's take a look at the toolbox that came out of that. For the pentagon, here's all the fundamental formula. When we took S5 in the 5th, the one that we got was, oops, come on, your pen. Who's this one? Okay, then we took S5 in the 5th, and we went to, for example, the 2nd coordinate system by going the 5th coordinate system to the 4th, 3rd, 2nd, and then from the 5th to the 1st to the 2nd, and we equated that. We got one of the subsidiary sets, and then we kept going and going and going, and we generated all these possible equations. There's a lot of duplication. For example, that equation appears 4 times. Basically, there, there, and where's the last one here? Because the definition of Z12 and Z21 are identical, and Z4 and Z4 bar. So yeah, there's some repetition in the toolbox, but it's okay. It's there for completeness. We have all our polar equations. So if you take the A vectors and extend them out, you can visualize the thetas now as being these metal links. And you can come out with these expressions that relate to the alphas and thetas again. And we generated these by changing the name. The only thing was odd is any U term lies to us a little bit. U, the definition of U, 1, 2, 3, 4, does not contain theta 4. So that was a little awkward, but that's okay. Subsidiary formula, not worried about these until Chapter 9. And then we gave you all the S and A vectors in 10 different coordinate systems. So we're going to go ahead and jump to the hexagon today. So let's go ahead and get to a nice, oh, let me back up. Before we go to the hexagon, there's a nice picture there, so I might as well show it. We went ahead and we set up this problem where we said given theta 5 and given theta 3. And I think we looked at, if I go for theta 1 first, what's the equation, and what theta 2 first, and all that. And we wound up, there was an A case and a B case. And I just wanted to show this one picture because this was a numerical example. It's in the book. So in both of these pictures, this link here, 5,1, is fixed to ground. And the viewpoint is the same in both pictures. So it's like you're standing there looking in the same direction. And what I want to point out is theta 5 and theta 3 were given. So in this picture, when I look at the relationship between those red pieces, right, it's the same. And because theta 3 is given, if I look at the relationship between that piece of metal and that piece of metal, it's the same. And yet you can see that there's an A and a B case. For example, theta 1 for the A case would be that, and theta 1 for the B case, came out to be that. So the numerical example in the book, I just wanted to show that picture. And it's a pretty picture. And it kind of reinforces the idea about how there were two solutions and da-da-da. Okay, so we're going to go into the 6 and 7-sided. So for the 6-sided, this is the pretty view of it, of what it's going to look like. So this link here is fixed. What kind of problems are we going to do? We're going to do problems where we're given all the alphas, and then I need to look at the mobility of this to say how many thetas do I have to give you. So it turns out that the mobility of a spherical closed-loop mechanism is the sum of the freedoms of the joints minus 3. And I got 6 revolutes minus, so it's a 3 degree of freedom. So I have to give you 3 thetas. So think of it that way, is we're going to do a problem. Given all the alphas and 3 of the thetas, then we're going to solve for the other 3 thetas. It turns out there will be an A and a B case. If I don't give you 3 thetas, you can't, you can't solve it. It's a 3 degree of freedom thing, so I can't mess you up and not give you that. So how are we going to attack that kind of a problem? Well, here's like a particular problem we're going to look at is given all the alphas, and suppose we're given those 3 thetas. There's the unknowns, and we're going to decide who we want to go for first. And but to get there, first thing we're going to do is build up our toolbox. And again, what I'm hoping at the end of this lecture, though, is that when we attack this problem, given those 3 thetas, how do you go into the toolbox and find it? And then we're going to do a 7-sided and do the same thing. That finally you're going to say, I get it, I can do it, and we're teaching, I don't want to say by boredom, but it's like they're all pretty similar, the way that we're attacking these. So I'm hoping that you'll feel that way at the end of it, that yes, I got this, I can do these problems. And also you want to think of it as, for these problems that we're doing, there's not a problem I can give you that you can't do on these, right? If I give you 3 thetas and you just decide who you want to go for first, and you're going to go in the toolbox and you're going to find it, and then you'll probably look at the buddy equations. So you really want to kind of go at it with that sort of attitude that there's nothing I can ask you that you can't do. And I think when you go back and look at some of the old exams, you'll see that I'm running out of things to ask about this chapter, but here we go. Let's see, we got to build a toolbox. So if we take S6 in the 6th, and we know that's 0, 0, 1, and we brought that back to the first a long time ago by what, R2 to 1, R3 to 2, R4 to 3, R5 to 4, R6 to 5 times S6 in the 6th. And what we got for that was, I think it was X, is it 5432, Y5432, and Z5432. So the notation was introduced. But now what we can do is imagine that the first coordinate system is aligned with the 6. So the 6 has the Z of the 6 along S6, and the X is along perpendicular to that plane, A61. So that's our X of the 6. And the first coordinate system, if we were to draw that one, is, oh, I thought I was changing color here, but the first coordinate system is Z along S1, and then the X is perpendicular to that plane. That's the X of the first. So if coordinate system 1 is aligned with 6, so we're going to rotate by the angle alpha 6, 1 about the X. Right, then we started with the blue coordinate system. We're going to get the Z lined up this way. And then we're going to rotate theta 1 about the current Z, and you're going to wind up in the first. So it's the same as what we've been doing before. And if we do all that work, what you're going to wind up with is, what, S6 in the first is going to wind up being 6, 1, 1. And when you equate that to that, and that to that, and that to that, you get fundamental sine, cosine, cosine law. So kind of going quick. I mean, we did this one a long time ago. That's where we introduced the notation. But, those 2 rotations, one is aligned with 6, and then, and I just know that's what's going to come out if we do all that work. So I'm just being a little bit lazy and not multiplying that all out today. But with that, let's go to the appendix and see what's in there for the hexagon. So the one that, from taking S6 and going to the first coordinate system, is that right there. And then if you did all the other possibilities, like let's take S6 and go the other way one step. Let's go to the fifth coordinate system. Go the shortcut and the long way and equate them, you'll get another one of those sets. And then if you take all the other ones and take one step to the left and right, you'll get a total of 12 fundamental sets. So you say, okay. Then what we're going to do is to generate some more equations for our toolbox was, we go back to the picture here, what if I take S6 in the sixths and I come back to the second coordinate system? So I do 2 steps that way and 4 steps that way. I'll get a, again, I just don't feel like doing the math, the results in the appendix. You're going to get one of the subsidiary sine, cosine laws. And then we're going to take S6 in the sixths, and we're going to go to the third. You'll get another set. When we do all those possibilities, again, what Dr. Duffy's approach was, let's just go ahead and do all that math ahead of time, put them in the toolbox so that if I need these equations, I don't have to prove them from first principle all the time. We wind up with this giant toolbox of equations. Right, there was our fundamental formula from taking one step with those vectors, and you'll get this subsidiary set. I think that was from 2 steps, and there's another set from, that might have been the 3 steps, like S6 in the third, and then I forgot what got this one. But we have all these equations. Now, when we look at all of the whether they're fundamental or subsidiary for the 6-sided hexagon, we still notice the fact that these cosine laws, whether they're fundamental or subsidiary, have 4 thetas. And these all have 5 thetas. There's 4 over there and 1 over there. So again, all the little things that we saw from the triangle to the quadrilateral to the pentagon, the idea that the cosine laws have less thetas. So when we do start our problem and decide who we want to solve for first, we're going to look over here. Okay. Then you can generate all these polar equations. We haven't had to use them at all, but there are these relationships of let the A vectors extend out and change the names in those the regular equations, and you get all the polar equations. And there's some stuff that we're not going to need till chapter 9, and then there is all the directions of all the vectors in 12 different coordinate systems. 6 of them are the standard coordinate systems that we've been working with, and there's 6 bonus ones. So for the hexagon, we got this giant toolbox. So I'm going to go all the way back to here, and we're going to say, pretending we did all that work and generated this toolbox, let's go ahead and do one of these problems. Okay, so I'm going to sketch this on the board. Okay, so we've got and this is just like the planar representation of the pretty picture, the spherical 6-sided hexagon. So these are all revolute joints. And our problem statement said given, of course, all the alphas. And we're never going to change that up like on a test or something, right? I'm not going to, because we're trying to solve reverse analysis problems on robots, and for every link we're going to know all the alphas. So I'm not going to go nutso just for the sake of doing it to switch you up on that. Okay, we're given 3 of the thetas. This case, it said 6, 4, and 3. So what's remaining is thetas, let's see, 1, 2, and 5. So I'm going to go ahead and circle 6, 4, and 3 because I know those are given. Okay, so here's our problem statement. We got our giant toolbox, and it's just a matter of how to dig in, and it's your choice. It's not going to matter which one you go for first. We're going to start with theta 1. And again, this is the most important step of the whole thing, is can I go in that toolbox and look down that cosine, cosine laws, whether they're fundamental or subsidiary. There will be one where theta 1 is the only unknown. And what I like to say is it jumps off the page at me because I'm going to say that's the one I'm looking for. And I'm going to start off and say, I know it's going to be a cosine law. I'm going to start with 6. So yeah, it's okay to have theta 6 in there. Do I want to go this way and put a 5? No, right? I don't want 5 in there. I want that as the only unknown. Do I want to go this way and put a 1? Yeah, it's okay, because that's what I'm looking for. Do I want to put a 2, like to keep going? And no, I don't want theta 2. So I'm going to stop, and then I go 4, 3. So that's how I sort of memorized it, but I'm going to say, boy, I sure hope that that's in the toolbox. So like I do them by drawing the picture and circling, and to me it jumps off the board, you know, the equation. But just to verify, let's go in the toolbox and make sure we see that Z61 equals Z43. That better be an option. Oh my goodness gracious. And it is going to be in there 4 times, because this is the same as the definition of Z61 is equal to, you know, Z16. And, oops, I thought it was 4 times. Maybe not. That's okay. It's in there multiple times. Oh, that's okay. So definitely we've got, this is the equation we found in the toolbox where theta 1 is the only unknown. So let's expand this definition, and let's see, what do we get? We get a sine xs plus yc plus a cosine z, and I'm going to say minus z43 equals 0 to fill out that equation. 6, 1, I got to be careful. Do I put bars on there? And then, no, I'm going uphill. 6, 1, 2, 3. So it's 6, 1, 6, 1, 6. And then what's this guy? The next number is 2, and that's just the way that I memorized it. And when we look at this equation, here's the unknown, so I can factor that into S12Y6 plus S12S6 plus C12Z6 minus Z43 equals 0. That thing in parentheses, based on what we're given, is going to be a number. All right, we're given theta 6, and that's, to me, that's also the beauty of the notation. I know that that definition contains a bunch of alphas, but I got them all. I don't care which ones. And theta 6, I got theta 6. It's going to evaluate to a number, and the number, and over here I got theta 6, and I've got, wow, 4, 3. I got both of those. So everything in parentheses is going to be numbers, so holy cow. This is like I'm saying, we've seen the same thing when we did the triangle and everything else. No, I guess it was in the 4-sided one that we got it. A, B, D, and you know how to solve that. You know, we showed you 2 ways to solve it. When I took the class in '79, we did the tan-half angle method, and then I think I mentioned Harvey Lipkin came up with the other method, which does not blow up anywhere near like the tan-half angle method. So that's the one that we wanted you to do for your homework. So again, when we attacked this, we said what we're given. Here's the unknowns. Who do we want to go for first? We went in the toolbox and found an equation that theta 1 is the only unknown, and it factored into the same format, a cosine 1 plus b sine 1 plus d equals 0. So our solution tree is given theta 6 and 3 and 4. We now have an A and a B case. So what's left is to get the corresponding values for 2 and 5. And yeah.
Are we able to do the ABD on angles other than theta 1? Like, can you do ABD?
Oh yeah, if we get, so the question was, what if we had, you know, and we're going to see it in a minute when we go for theta 2 first. Like you'll have an A, in that case, you'll have an equation like this with another. And you'll say, yeah, what are the values of theta 2 that would satisfy that? So that function, though, will still do the job. So now we got the 2 values of theta 1, the A and the B case. And you know, we need to get the corresponding. And I kind of expect, based on what we've seen before, that when I take theta 1A, I should be able to get the sine and cosine of this to get a theta 2A. In other words, I don't want it to branch out again. For this theta 1A, there is one value of theta 2 that goes with it. So I need to get the sine and cosine. The same thing will happen with theta 5. I don't know where to start, so let's look at the buddy equations. I mean, I know I'm going to need two equations to get the sine and cosine of in this case, theta 2 and theta 5. And I got to dive in there and find these equations, but this is kind of silly. I call them the buddy equations work pretty good. Let's just look at these and see if they help us out. Okay, to be a fundamental over here, I would need to have 4 numbers, right, subscripts. I only got 2, so I know it's a subsidiary, so it's an x and a negative x star. And then we're going to look in the book, but it's going to be 6,1 is going to be 432. So again, when I went for this, I didn't know what was going to come out of these buddy equations, but they're worth a look, and they always work. It's not the only way to get the corresponding angles, but boy, it always works. So let's make sure that that's in there. x61. Well, there they are. Yeah. Okay. So what are we going to do with those equations? I've got 6 is given, 4 and 3 are given. I've got the a and the b case of 1. So these are going to allow us to get theta 2. So I'm going to expand x432's definition. xc minus y43s2 equals x61. I can take this negative sign and move it over there, negative y61. Expand that, it's going to be xs plus yc. Holy cow. So we're going to take the given theta 4, theta 3. That's going to be a number, a number, a number, a number. I'm going to take the given theta 6, and I'm going to take theta 1a numbers, solve 2 equations, 2 unknowns, 2 linear equations. I mean, holy cow, that is so nice. Then I'm going to take these same 2 equations, and I'm going to have to reevaluate these because I'm going to put theta 1, the b case, in there. I'll get new numbers on the right-hand side, and I solve those 2 equations, 2 unknowns. And to me, it's just so magical that, what are the odds I solve these 2 equations and 2 unknowns, and I look at my answers, and I square them and add them, and I get 1? I mean, it's a nice check that everything is still okay, but it's just wonderful. Everything works. So again, when I wrote down these buddy equations, I wasn't sure which angle it was going to help us solve for. I said, let me take a look at them. They always seem to do something good for us. So then, well, I know the definition of Z61 is the same as Z16. So let's look at those buddies. Okay, they're subsidiaries, and 1,6 is going to be 3, 4, 5. And we're going to go ahead and verify that. So basically, if you don't figure out how I'm like cheating to get those out of my head, but you do this and you look in the table and see what it equals, and it's going to be something good. X16. Yeah. And again, ahead of time, I didn't know how they were going to help us, but boy, they always do, because we're going to expand this definition. So I'll have x c minus y s, and that's going to equal x16. I'm going to put the minus sign on the other side and have x s plus y c. There's the 2 equations and 2 unknowns. I'll take the given 3 and 4, numbers. I'll take the given theta 6 and theta 1a for the numbers for the a case, solve it for the a case. Take those same 2 equations. I've got to reevaluate this for the b case of theta 1. Yeah, what you got? Uh-huh. Oh, the reason I haven't, so the question was, do you just expand these and all? And the reason, yes, you'll have to when you numerically go to evaluate them. You'll have to expand them, and then you'll say, what's in those definitions. Like this is going to have x bar, x1 bar, and y1 bar, and you got to expand those definitions. But based on everything we're given, you know all the alphas, and theta 6 is given, and then we do know theta 1a. So it'll turn into numbers. It'll evaluate for the A case. So it's kind of funny because, like you said, I'm skipping. There's a lot of work there. And here I am just going, oh, yeah, you get a number, you know. But, yeah, you got to expand all the definitions, and yep. No, so it's good that you noted that, because I'm just up here la-di-da-di-da, this look at, you know, but, yeah, 10 minutes later, for the A case, you finally got that number, right? So, yep. And when you do code this stuff up, it's so easy to, you know, expand in, I don't know, forget to put a bar over one of the single subscripts when there was supposed to be one, or accidentally put the wrong alpha, you know, to make a mistake in the code. It's really easy to do that. So yeah, those steps, for example, here, this is going to be a number, but yeah, I got to take the given, I got to expand all those definitions, I got to take the given thetas and the given alphas and evaluate all of that and turn them into numbers. So there's a bit of work there, but it will just go to a number. Okay, so we're in pretty, and then the same equations we're going to take, when we expand this, we're going to put theta 1b. For the B case, then, boom, we'll get that. Okay. So what we're going to do next is say, suppose somebody else attacked this and they said, I want to go for theta 2 first. Now, they are going to get the same A and B case solutions and stuff, but you know, let's see what happens on that one, because it doesn't matter who you go for first. So I'm going to say, hey, it's okay to have theta 2 in the equation. It's still okay to have 6, 3, and 4. So I'm going to start up here, and maybe I'll start, I know it's going to be a cosine law. And there's so many, like I'm going to start with 4 this time. Because if I started with 6, I got to stop, right? Because I don't want to put 1 in it. I thought maybe I'll start up here. And do I want to go this way with a 5? No. Do I want to go, it's okay to have 3 in there, because it's given. Can I go, it's okay to have 2, because that's what I'm looking for. And then do I want, if I go 1 more, I'll have a fundamental law, which is always nice. But no, I don't want theta 1. All right, I only wanted theta 2 is the only unknown. So I have to stop, and I say, oh, that's not enough subscripts to be a fundamental law, so I do this, and I take a step, and I take a step, and I get Z6. And then if I want to make sure I haven't messed that up, we just go to the toolbox, and let's make sure that's in there. Oh yeah, here it is. So ultimately, yeah, we're going to look at those buddy equations coming up, but so I've got the equation out of the toolbox that has theta 2 is the only unknown. So we're going to expand this definition. So this other one writes a little darker. X S plus Y C plus a cosine Z. And then I'm going to say minus Z6 equals 0. And again, we're going to regroup it as S12Y43 times C2 plus S12X43 times S2 plus. And based on what we're given, but this is the part where, 10 minutes later, you turn that into a number. Yeah, you got a question? Oh, when we went for theta 1 first? Yep. In that case, what we did is we wanted to go in the toolbox and find an equation where theta 1 was the only unknown. And I started off and I said, it's okay to have 6. It's okay to have 1. Oh, I don't want to put a 2. So I stopped and said, I could go in the toolbox and look and see what does that equal, but it turned out to be 4, 3. Oh, so could you use that then to get the corresponding? And the answer to that is yes and no. The issue is you are going to get the A and B out of here, but over here I'm going to get A and B, and I'm really not sure how does the A of this go with the A of that, or does the B of this go with the A? In other words, so yes, that sure seems nice, but I'm not sure how they line up. Yeah, if we did this equation, we might have to go with another equation to, I think. Oh, right, because you know how we've got like a cosine plus b sine? Yeah, we need to get another one so that we get two linear equations. Yep, that's what it was. Yep. But this could be one of the equations. So we're going to get, in this case, we're going to get theta 2 first, and when we do go for theta 1, like I've been getting those two buddy equations and just solving them out, but we could take one of the buddy equations and this equation, and it would do the same job, because you will get two linear equations and the sines and cosines. Yep, so that's how they go together. And there's nothing wrong with using that as one of the equations. It's just I fell into this trap of the buddy thing always works, so I just keep going for it. Okay, so for theta 2 first, went in the toolbox, found that equation. You know, here's our unknown. We regrouped it. Everything in parentheses is, although, you know, you have to do a lot of expansions and calculating, but they're going to be values. So I have an a cosine 2 plus b sine 2 plus d equals 0. So I know and then to get the corresponding other values of, I'm going to look at, for example, x432 and y432. And it's going to be, because there's not enough subscripts to be fundamental equations. So 432 is going to be 6,1. And then we're going to double check that that's in the, yep. So then when I look at this, I'd say, well, I know 4 and 3 and 6, and for the A case and the B case, I know theta 2, so yeah, this is going to get us theta 1. So we're going to expand x6,1. I got to be careful with the bars and stuff, but it's x6c1 minus y6s1, and that equals x432. And here I'm going to move the minus sign and expand x61 star. And again, here's our unknowns. So it's two equations, two linear equations, and two unknowns. x6 is given, so number. Over here, x3 and 4 are given. I'm going to take theta 2a, get numerical values. Then for the A case, then I'm going to take the same two equations. I'm going to reevaluate this with theta 2b. I'll get sines and cosines. And then I said, well, Z432's definition is the same as Z234, so I think I'll look at, and that whole thing about where I switch those numbers and then that has no merit, it's just a mental trick I found to find two good buddy equations. Two equations. So let's look in, in 2, 3, 4. It's going to be 6, 5. So there's no, there's some logical reason why I did that. No. It's because it was closed book and I was dying. X2, 3, 4. So we go, here they are. So again, what is that going to do for us? Well, I know theta 3 and 4. I know theta 2 for the A and the B case. And I know theta 6. I'm going to expand these, and we're going to get the two equations in S5 and C5, which will get us, again, for the A case, the corresponding theta 5, and then same for the B case. So again, to go for theta 2 first, that was the most important step, was finding that equation that had theta 2 as the only unknown. And again, I just do it from it just jumped off the page when I circled what I knew and I underlined who I was looking for. So we're going to do it one more time. We're going to go up here and say, I'm going to go for theta 5. Okay. So this time, and I'm going to go up here, and I'm going to say Z, and I'm going to put a 6. It's okay to have 6 because that's given, right? I don't want to put 1, right? I want theta 5 is the only unknown. Is it okay to put 5? Yeah, that's what I'm looking for. Hey, is it okay to put 4? Yeah, that's given. Is it okay to put 3? Yeah, it's given. Hey, I got enough subscripts to be a fundamental law. So let's double check that that's in there, that that's one of our fundamental laws. Going up top here, fundamental laws, Z6543. Yeah, here it is. So again, I just drew the picture and started writing down Z something, and basically I made sure I did not put 1 and 2 in that equation. Okay, so we need to expand that so that we can, basically we want to get it into A cosine 5 plus B sine 5 plus D equals 0. So I kind of have a choice here. I could expand this, and I'm going to get XYZ 654, and then I have to expand those terms to get what? XYZ 65, and then I have to, oh my goodness. So you know, I might do this. I know that this definition is the same as that definition. I'm going to expand that one because the 5 is going to pop out sooner. So yeah, you're going to get the exact same A cosine 5, but the A, B, and D are going to be the exact same, but I'm going to go with that one. Okay, so expand this one's definition, and you get sine x of s plus y c plus cosine 61 z 345, and I have to go minus c12 equals 0. Oh, and then this is a bit of a pain because I have to say where x345's definition is xc minus ys, and y345 is, oh my goodness, cosine xs plus yc minus a sine z, and z345. So this one seems to be more work, but it's okay. And then I have to substitute that in there, and that in there, and that in there, and ultimately, and again, if I go ahead and say A is equal to whatever, I'm probably going to make a mistake on the board today. But that's what's going to happen. We're going to take, again, here's our unknowns. So I have to take the C5 terms here and group those together, and then the S5 terms here and group those together, and then everything else that's left over will be in the D. But it will go into that format where the A, B, and D, based on what we're given, are going to turn into numbers. So we will have an A and a B. I just feel like I've got to be a little bit more careful when I do this regrouping to figure out what A, B, and D are, but it's not terrible. Then the next thing is, how do we get the corresponding? And they say, well, this guy did so good, let's look at our buddy equations. Turns out they're fundamentals. 3, 4, 5, 6. The way I remember it is it's next angle, next side. Next angle, next side. Again, I'm going to take 3, 4, 6 are given. I'm going to take theta 5a, and this is probably 20 minutes later, I get numbers for the A case. And boom, though, I got the A case, sine and cosine. And then I'm going to take the 3, 4, 6 and theta 5b, get new numbers here. Boom, new numbers. There's one angle left. I'm going to try these buddies. 6543. Fundamentals. 6543. Next angle, next side. Next angle, next side. Holy cow. Yeah. So these buddy things always work. You know, it seems kind of crazy to, because again, you don't have to use those two equations, but gee, they always work. So again, I'll take the given 643 and I'll take theta 5a, get numbers. Then for the A case now. So I guess what happened is when we went for theta 5 first is it was a little harder to generate the theta 5 equation. But when I went for the other ones, I didn't have to solve two equations, two unknowns. I just, boom, the fundamental equations, they just popped out. So that was kind of nice. So how do you feel about this stuff? Yeah, it's like, it's the same thing every time, right? Because we got about 10 minutes left, and I'm hoping to like I don't feel like doing this on Friday, you know. Getting there? Okay. 7-sided. When we go to the 7-sided, boy, it's a beast. So it's like, holy cow, we're going to do that in 8 minutes. Oh, so here's the 7-sided. One of the links is fixed. The kind of problems we're going to do is this. Given all the alphas, it's a 4 degree of freedom system, so I have to give you 4 of the thetas. I have to give you 4 of the thetas to solve for the other 3. I guess I'm going to just, one of them has to be fixed. I keep drawing that one. So we're going to say, given 4 of the thetas, so what if I pick theta 7, theta 2, theta 3, and theta 5? Because, I mean, I don't care which 4 you give, we can solve it. If I don't give you 4, then, hey, it's a 4 degree of freedom system. You can't solve it if I don't give you 4. So who's left is 1, 4, and 6 in this example. Okay, our toolbox, we're going to generate the giant toolbox. Take S7 in the 7th, and remember how we brought it all the way back to the first coordinate system, and we got X, 6, 5, 4, 3, 2, and Y. But on this picture, right, the 7th coordinate system, and then perpendicular to that plane was A7. That was the X. And then the first coordinate system, it's the same story. The Z of the first is here, and the X of the first is perpendicular to that plane. And again, if I align the first with the 7th and we rotate alpha 7, 1 about the x-axis followed by theta 1 about the new z-axis, you get into the first, and we use that information to get R, 1 to 7. We transposed it to R7 to 1, and then we took S7 in the 7th, got back to the first. And here's what we wound up with. When we went the long way, we got the direction of S7 in the first was X65432. And when we went the short way, we got S7 in the first to be 711. So again, I just haven't done all the, 1 is aligned with 7, and multiplied it all out. So when we equated that, we got our sine, cosine, and cosine law. So there's 7 of those vectors, and you can take one step from the 7th coordinate system to the first, or a 7th coordinate system to the 6th, and then you can take S6 and go one step to the 7th coordinate system, or to, oh my goodness, and all those possibilities. But we would need a whole nother semester to do all that on the board. So I'm going to just jump down to the toolbox and say the heptagon. So it seems kind of crazy, but heptagon. Here we go. So when we took S7 in the 7th and brought it to the first, and we went the 2 different ways, we got these equations. And if you did all the other possible permutations, again, when we look at these, the cosine laws have 5 thetas. These have 6 thetas. So again, when we start the problem, we're going to go into the z column. Okay, then we could take S7 from the 7th, and we could go to the second coordinate system, take 2 steps and 4 steps, and you'll get some subsidiary equations and do all the possible. So you look bored. You look bored. No, I'm going to compliment, because I want everybody to look like that. Means you must got it. You know what I mean? The way, I didn't mean to point you out and pick on, I'm not picking on you, but they're all the same. I'm hoping everybody will say, oh my goodness, I don't need to see this anymore. So that's why I said it was a good thing. I don't need to see this anymore. I got the idea. You're generating these toolboxes from all these steps. And so I didn't mean, I wasn't picking on you. I meant it as a compliment. Okay. So let's look at our toolbox. All these subsidiary formulas, still these all have 5 thetas. These all have 6. And then I could take S7 and go to the third coordinate system 2 ways. And oh my goodness gracious, look at all the equations. And then there's all the polar equations. And then there's in 14 different coordinate systems. Okay, so we got this big toolbox. Let's go ahead, because, oh shoot, we got 3 minutes left, so I am kind of pushing it here.
Do you have to solve for theta 4 first for this one? Is there only like one way you can
No, you can go for any of them. So let's circle who we got. 7 is okay to have, 2 is okay. So the question was, do I have to go for theta 4 first? But no, you're still able to do any of them. Let's go for theta 1, because in that case, I would say Z7, I don't want to put a 6. Hey, it's okay to put 1. It's okay to put 2. It's okay to put 3. I don't quite have enough. I don't want to put 4, though. So I don't have enough to be a fundamental law, so it's going to be a subsidiary. And when we go in the toolbox, I go Z5 or Z5 bar. So in that equation, theta 1 is the only unknown. 7 is given, 2 is given, 3 is given. Now, I probably would not expand this one, just like we did last time. I would probably say, well, it's the same definition as that, because at least the theta 1 will pop out a little sooner. And I will be able to get that into this format. Then I would say, well, let's look at the buddy equations. Okay, we've got a couple minutes left. 3217. Oh, it's going to be 5, 6, and I would go ahead and double check that in the appendix, that it was in there. What is that going to get us? It's going to get us the 2 equations and the sines and cosines of theta 6. Because theta 5 is given, theta 7 and 2 and 3 are given. I'm going to take theta 1a. Based on the given in theta 1a, I get numbers over here. I'm going to expand that and get the 2 equations, 2 unknowns. And then I'm going to look at the other buddy equations, 7, 1, 2, 3. Not that, again, this is the only way to do it, but man, it works. And then I go 7, 1, 2, 3, and if I look in the book, it's going to be in the appendix, it's going to be 5, 4. So I'm going to expand this to get the sine and cosine of theta 4 to appear. Theta 5 is given. Over here, again, I'll take theta 1a and the given stuff and get numbers for the A case. And then I'll take the same equations and put theta 1b in and get new values here, 2 equations, 2 unknowns. So yeah, so if you go for theta 1 first, that would have been the equation. The Z, 7, 1, 2, 3, Z5. And then the buddy equations kicked out the sines and cosines for the other. Again, the calculations to write the program would take a while, but okay. Oh, man. So we're at the official end point, but I'm going to do 2 quick things. What if I decided to go for theta 4 first? So I'd say it's okay to have that. I'm going to go Z. It's okay to have 2. It's okay to have 3. It's okay to have 4. It's okay to have 5. I need one more, though, to get a fundamental. I can't add 6, and I can't add 1, so I'm going to stop. And it turns out that it does equal Z7. So that's the equation that has theta 4 is the only unknown, and it will factor into that format, a cosine 4 plus. So to me, that's the most important step, is finding that first equation. What if we went for theta 6 first? It's okay to have that. I'd say, well, I don't know. It's okay to have 5. It's okay to have 6. It's okay to have 7. Oh, I got to stop. And it turns out that that is in the appendix. So if I went for theta 6 first, again, I would have to expand those definitions twice, and then I would group it into that format, a cosine 6 plus b sine 6. And then I would look at the buddy equations, x5, 6, 7, and y, and then x7, 6, 5, and y, and everything would pop out. So we kind of, like you said, I was getting tired of doing these, so I wanted to move on to something new for the next class. But you did the 4-bar, which is same idea, you know, as this is what we had. You did that for homework. So is anybody happy? We're happy it's over anyway. Take a look at the old tests and stuff that are out there, and yep, you'll be okay. All right, so Friday I'm going to make a video and post it online, and then I'll be back in here on Monday. Yeah, question?
For the homework, can you post what theta A's and theta B's we should get so we know our code is right?
Oh, for the a cosine one, for that? Or for the 4-bar? The 4-bar one, I'm kind of hesitant just because, I don't know. I guess it's not going to hurt. I'll go ahead and post what I got for that. Yeah, I'll go ahead. But I'm going to walk up the hill, and I'll throw it on right now. Yep. But it's funny. I feel like I'm posting the answer to the homework, but that's okay. Okay, so we'll see you on Monday.